In this video, I'm going to explain the greatest common factor. Now, the greatest common factor, or GCF for short, is the greatest number or factor that divides into both of the given numbers. So say I give you the numbers 6 and 14, and I tell you to find the greatest common factor. One way to do it is to list out all of the factors. 1, 2, 3, and 6 are the factors of 6. 1, 2, 7, and 14 are the factors of 14. Now, once you see the list of factors, look for the greatest one that they have in common. 1 is in common for both, 2 is in common for both, 3 and 6 are not in 14, so 2 would be the greatest common factor. So GCF equals 2. Another way to find the greatest common factor is to do the prime factorization first. So the prime factorization of 6 would be 2 and 3. The prime factorization of 14 would be 2 times 7, because both 2 and 7 are primes. Now we find the numbers that are in common. 2 is the only number in common, so the greatest common factor is 2. Say I give you the number 10 and the number 20. Starting with the first method, let's find all the factors. So 10 is 1, 2, 5, and 10. For 20, we have 1, 2, 4, 5, 10, and 20. 1 is similar, 2 is similar, 5 is similar, and 10 is also similar. And 10 is the greatest number that goes into 10, so 10 would be the greatest common factor. So GCF equals 10. If we were to do this the prime factorization method, we would write 10 and break it down in the prime factorization, which is just 2 and 5. And then the prime factorization of 20 would be 2 times 10, and this 10 breaks up further into 2 times 2 times 5. And now we circle the ones they have in common. So 2 is in both of them, and 5 is in both of them. So we're left with 2 times 5 and 2 times 5. And we know 2 times 5 is 10. So the GCF is 10. So when doing it the second method using prime factorization, you would multiply the factors that they have in common. So how would you find the greatest common factor of a monomial? Say I give you 12x squared y and 18xy. We're going to use essentially the same method that we just used. So let's split these up into the prime factorizations. So 12 is the same as 2 times 6 times x times y. 2 is a prime, and x, and y are all expanded out. But the 6 is a composite and can be rewritten as primes. So now we're going to have 2 times 3 times x times y. 2, 2, and 3 are all primes, and therefore this is the prime factorization. For 18, we can break 18 up into 2 times 9, and then x times y. This 2 is a prime, x and y are expanded, but this 9 is not a prime, but we can break that up. So we're going to have 2 times 3 times 3, because 9 is 3 times 3, times x times y. 2, 3, and 3 are all prime. Now we find what they have in common. So each has a 2, There's not another 2 on this side. There is a 3 in each of them. This side has a 3 that this one doesn't. There is at least one x, and there is one y. So rewriting this, we would have 2 times 3 times x times y. 2 times 3 is 6 times x times y. So 6xy would be the greatest common factor between those two monomials.